Understanding the work-energy theorem. Imagine a depiction of a moving car. Have you ever wondered how we can explain the changes in motion of objects within the physical world? That's where the work-energy theorem comes into play. Welcome to this video where we will explore the work-energy theorem. By the end, we'll have a solid grasp of this fundamental concept in physics. So what is the work-energy theorem? In essence, it's a principle that relates the work done on an object to the change in its kinetic energy. It is a powerful tool for understanding the dynamics of motion. In physics, a profound principle that connects the physical effort we apply to the motion of objects, known as work-energy theorem. Here's the equation for the work-energy theorem. W equals delta KE. First, work. Work is done when a force is applied to an object, and the object moves in the direction of that force. Work is calculated as the force applied times the distance over which it is applied. Work is done when a force, or F, is applied to an object, and the object moves a certain distance, or d, in the direction of that force. Mathematically, it's expressed as, for instance, when you lift a heavy object off the ground, you're doing work against gravity, and the work done is the force of gravity multiplied by the distance the object is lifted. Second, energy. Energy comes in various forms, but for the work-energy theorem, we're interested in kinetic energy, or KE, which is the energy of motion. The kinetic energy of an object is given by the equation KE equals 0.5 times m times v raised to 2, where m is mass and v is velocity. Energy comes in various forms, such as kinetic, potential, and thermal energy. In the context of the work-energy theorem, we're primarily concerned with the kinetic and potential energy. Kinetic energy is the energy of motion, while potential energy is the energy associated with an object's position. Now, let's tie it all together with the work-energy theorem. It states that the work done on an object is equal to the change in its kinetic energy. So when you do work on an object, you're transferring energy to it in the form of kinetic energy. If the work is positive, the object's kinetic energy increases, and if the work is negative, the kinetic energy decreases. On the other hand, potential energy, or PE, depends on an object's height, or age, and is calculated as PE equal m times g times h, where m is the mass, g is the accelerated due to gravity, and h is height. The work-energy theorem mathematically is expressed as W equals delta KE. For example, when a roller coaster moves downhill, gravity does work on it, increasing its kinetic energy. The work-energy theorem tells us that the work done by gravity is equal to the change in the coaster's kinetic energy. For another example, a ball being dropped from a height. Let's illustrate this with an example. Imagine you're holding a ball and you drop it from a certain height. Gravity does work on the ball as it falls. The work done by gravity is equal to the force of gravity, or mg, times the distance it falls, or h. So, this work done is transferred into the ball's kinetic energy. As it falls, its speed increases, and so does its kinetic energy. However, the real-world applications of the work energy theorem has various applications. It explains how engines convert fuel into motion, or how a pendulum swings, and even how you use energy when running or cycling. As for the pendulum swing, when you pull a pendulum to one side and release it, the work you did to lift it is converted into kinetic energy as the pendulum swings back and forth. The work energy theorem is a crucial principle in physics that connects the work done on an object to changes in its kinetic energy. It helps us understand why objects move, how machines operate, and much more. The work energy theorem is a very powerful concept that connects the work done on an object to changes in its kinetic energy. It's a fundamental principle in understanding the physics of motion. It helps us understand why objects move, how machines operate, and much more. Whether you're using a machine, or riding a roller coaster, or simply walking, running, or exercising, the work energy theorem is at play, shaping our world and explaining the fascinating interplay between work